here. The first one is zones are overlap. Okay. And circuit breakers are located in the overlap region. And the third one is for a fault occurs anywhere in the zone, all CB in the zone opens to isolate the fault. So the circuit breaker will open to isolate the fault, means that the fault current will not flow to any other place. Okay. Okay, so let's zoom in here. Okay. We have, you can see here this figure 10.25. This is from the textbook. We have 1, 2, and 3 generator here. 1, 2, and 3 transformer. We have bus. This is bus. Okay, and we have a line, which is the transmission line. Okay, and the square one is the circuit breaker. You imagine that it is not there now. Okay, before we draw the zone. Okay, according to this character. Okay, so what happened if we draw the zone? So here we can see one zone here. Okay, reference is the transformer. Okay, transformer here. Okay, because generator is connected to transformer, so we consider it as one. So it's one zone here. Okay, the next zone is the bus. Okay, refer back to this slide, bus. Okay, the first one we have transformer with generator, and we have bus. Next one. So, okay, we need to draw it like this, so that these two zones, zone 1 and zone 2, is overlap. Okay, as written here, zones are overlap. So this is what the meanings of overlap. So inside the overlap zone, we put one circuit breaker here. This is breaker B1. Okay. Okay, then next zone is the transmission line, the power line. Okay, this is one zone. So we draw like this, and we put one circuit breaker inside this. Okay. Okay, then we go until all zones are drawn. Okay. Okay, we can create all zone here. Like here, we have 1, 2, and 3 line. Okay, and one bus. So we need to combine like this. Okay, to make it overlap. So in each overlap region, the line with bus with line here. Okay, and the bus, this bus 2 with this line. All the zone must be overlap. So we put one circuit breaker each. One here, and one here. And until we create all zone in the region according to this character here. Okay, zone must be overlap. Okay, then after we create the overlap zone, we put one circuit breaker in the overlap region. Okay, like here. Okay, in the overlap region, and then when fault occurs anywhere in the region, all circuit breaker must be tripped. So as shown here, okay, this mark, this X mark here, P1. Okay, when circuit breaker, when fault occurred here, okay, when fault occurred here, so all circuit breaker in the region must be tripped. So what CB will be tripped? So all circuit breaker in the region. Okay, so this one, this one B1, B21, the circuit breaker, then B23, and then B24. That's it. Okay, because fault current, if B24 is not open to isolate the fault current can flow through here and will affect this transmission line, zone 5 here. Okay, so we need to close all doors for the fault current not to flow outside of the zone. Similarly here, if it's open, it can go to the fault current can go to zone 8, and if B21 open, not closed, close, not open, then the fault current can flow here. Okay. Okay. Jadi fault current circuit breaker mesti isolate lah, mesti buka macam buka switch tu. Dia buka switch, jadi circuit tak sambung, then fault current tak akan boleh keluar daripada zone ni. Okay. Okay, as shown in this slide, we have generator. This is one zone, and this is circuit breaker. Then next zone is the the bus, and this is another circuit breaker, transformer, another circuit breaker. Then zone 4 for each feeder, and for each feeder we put another zone 5, zone 6, and zone 7. Okay. Okay. This is location of CT. We'll discuss this later in the next slide. Okay, let's take a look. What is the component needed for protection? Okay, the first one is circuit breaker, as I explained just now, a lot of time. So the duty is to turn on or turn off, switch on or switch off. Okay, once or repeatedly several times. Different electrical circuit during normal as well as operating condition. So it can be turned on and turned off. While making or breaking the switching contact, there is a transitionary stage of arcing between the contact, while it's governed by electrical discharge between the contact. So sometimes in your house you can see spark, electrical spark, when you turn on or turn off the switch at your house. Okay, so you can imagine that is a kind of arcing, but for a longer time. Arcing is spark for a longer time. Okay. Okay, the second one is transducer. Okay, what does it mean by transducer? Okay, this is to convert. Okay, for here, convert the voltage or the current. Here we have a current transformer, and the second one is a voltage transformer, and sometimes also known as potential transformer or power transformer. So it is to step down the current or the voltage so that we can read the value. Because if we reading a value at very high current, for example 2500 amps, okay, is very dangerous. High current can cause overheating. Okay, so we need to step down the current by using current transformer, or step down voltage by using voltage transformer. Okay, the third one is relay. The main function of the relay is to isolate a faulty section with the least interruption to service by controlling the circuit breaker. So this is the component that will control the circuit breaker. Okay, when relay is energized, it will control, it will open the circuit or close the circuit of the circuit breaker. Okay, it will move the moving contact of the circuit breaker. So for circuit breaker, usually we will have two component, moving contact and fixed contact. So during fault, when the current transformer or voltage transformer detects abnormality in the voltage or current, it will send the signal to relay, so that relay will operate the circuit breaker, will open the circuit breaker. Okay. Thus, the relay may be designed to detect and to measure abnormal condition and close the contact in the tripping circuit. Okay, there are two types of relay: electromechanical or electronic or static relay. Okay, this one is a fuse. Okay, as you know, fuse is fused when overcurrent flows to fuse, the fuse will break up and will never be connected again. So it's one-time use. So these components must be carefully chosen and installed and well looked after if there are not to be sources of weakness in the maintenance of the reliability of the protection. Most LV fuse elements are made of copper. Okay. Fuse elements of fast-acting fuses and HV fuses are primarily silver-plated copper is also commonly used. As a rule of thumb, fuse elements of time delay fuses contains low melting points. For example, tin or zinc and alloys thereof. Okay, formerly use alloy containing lead and cadmium. Okay, let's take a look. So here we have four components of protection. Okay, the first one is a circuit breaker, then transducer, relay, and fuse. Okay, this is the equivalent circuit of a transformer. So here we have two transformer, which is those two transducer, voltage transformer and current transformer. I think you are very familiar with this equivalent circuit. You must be familiar because you already taken electrical motor, right? EM, sorry, electrical machine subject. Okay, so this is the equivalent circuit of the transformer, where all quantities are referred to secondary side. Okay, if you don't know what is secondary side, refer back to your EM machine, EM subject notes. Refer to primary, refer to secondary. What does it mean? Okay. Okay, the secondary windings fits the protection system with a current or voltage. This current being as near as possible a faithful replica of the power system current, but reduced by some factor N, which is the CT ratio. Besides reducing the current level, the CT also isolate the relay circuit from the primary circuit, which is a high voltage power circuit, and allows the use of standardized current rating for relays. CTs or current transformer are usually designed to have rated secondary currents of 5 amp or 1 amp. So, what do you understand by this sentence? CT also isolates the relay circuit from the primary circuit, which is a high voltage power circuit. What does it mean by isolate? Anyone can answer? Any idea? Separate circuit. Yeah, thank you, Amirul Shafiq. What does it mean by isolate? Integrate. Macam mana tu? Boleh buka mic lah nak jawab. open circuit. Open circuit. Mana? Okay, imagine this is the first, the primary winding, secondary winding. Okay, so it's like this, right? It is not electrically connected. That's the meaning of isolate. It's not electrically connected. Okay. Okay, for an ideal transformer, the power is fully transformed from the primary to the secondary. If the voltage is high here in the primary and it is a step down transformer, so if voltage high here, voltage will be low here, right? How about the current at the secondary? What is it? Will be high or low? Because the power is maintained, P equals to VI. V here high in the primary, secondary is low. What will happen to the current at the secondary? Are you sure, Cik Muhammad Asad Safwan? Yeah. Okay, because power is maintained, right? So power is maintained. P1 equals to P2. So if V1 is high, V1 I1 equals to V2 I2. Okay, so V high, this one V low, current here is low, current here will be high. Okay, thank you, Wan Nur Aina. Okay, so this is what it means by electrically isolated. Okay, so if you want to remove any noise whatsoever, you can use 1-to-1 transformer. Okay, 1-to-1 means that same ratio, which can transfer the signals, but can block the maybe high frequency region. Okay, let's move on. Okay, types of CT. There are 4 types. It's written here. CT, wound type CT, bushing or bar type CT, oil immersed bar primary CT, and air gap. I can show you the picture. Wound primary type CT has conventional windings, primary and secondary, form of copper wire wound round a core. Okay, this is not merely a copper wire, it's a enamel. Okay, enamel. Enamel copper wire. Okay, it's insulated copper wire. It's not a bare copper wire. It's used for auxiliary CTs and for any low or moderate ratio CTs used in switchgear of up to 11 kV. Okay, for bushing or bar type CT, the secondary windings form a toroid which should occupy the whole perimeter of the core. Such CT normally have a single primary conductor, sometimes permanently built into the CT and provided with necessary primary insulation. Okay, this is how it looks. On the left is bar type CT. On the right side is bushing type CT. So this is the primary conductor, this copper. Okay, this copper is primary conductor. Okay, this one is bush type. Bush type conductor. From the outside, This one also bushing type current transformer. So inside this one, you can see is like this. It's oil immersed type where we have oil inside this transformer. The primary conductor is U-shaped. This one is the primary conductor. This one. Primary conductor, then the secondary is wound at this area. Okay. So if you go to pencawang masuk utama, okay, main substation, pencawang masuk utama, outside UMP or maybe near to your house, you can see these things on the field. Okay, so you may know, you may recognize it is a current transformer, and the ratio can go up to 1 or 5 ampere on the secondary. So the highest current is 5,000, so we can step it down to 5,000 amps. 5 amps. Okay. For voltage transformer is an open circuit transformer whose primary winding is connected across the main electrical system of the voltage being monitored. A convenient proportionate voltage is generated in the secondary for monitoring similar function as the current transformer. Okay, the most common voltage produced by VT is 100 to 120 volt according to local country standard, and the voltage range can in the primary can go up to 8,000 kilovolts or maybe more. Now there are 1,000 kV transmission line, not in Malaysia, of course. What I know is in China, maybe in India, maybe in Europe. Malaysia only we have the highest voltage is 500 kilovolts. Okay, and the capacity of a VT is normally represented in the VA rating, which indicates the maximum load that can be connected across its secondary. Okay, this is how the connection schemes looks like. If we have CT, this one is CT, and this one is this one is CT, current transformer, and this is VT, voltage transformer. Okay. So that's the end of our class today. This question related to electrical machine, you can do this, you can try, and you can get the answer in this link if it is still there. If not there, let me know in the WhatsApp. Okay, any question? That's the end of chapter 1. We'll go to chapter 2 tomorrow. Any question?
Sir.
Yeah.
Yang tadi yang circuit breaker tadi kan dekat overlapping tadi tu.
Ya.
Function dia bubur situ tu apa sir?
Sekejap saya buka balik. Ni. Function apa?
Circuit breaker tu tadi, CB tu kita bubur situ untuk buat apa?
Ini breaker ni. Ni yang CB saya tunjuk ni ke?
Yang tadi saya suruh masuk ke tu dekat zone overlap.
Ni. Nak open circuit ni.
Sebab dia nak suruh open circuit lah.
Nak suruh open circuit bila berlaku fault. Kalau berlaku fault, tengok contoh fault dekat sini.
Betul.
Kalau fault dekat sini, zone dia zone 4 ni. Zone 4 ni dia bertindan dengan zone 3, dengan zone 8, dengan zone berapa ni? Zone 5. Jadi semua circuit breaker ni dia akan trip, dia akan buka. Current tak akan boleh flow.
Maksudnya sebab dia fault tu je lah, sir.
Ya,
Sebab fault tu lah.
sebab apa?
Berlakunya fault tu, sebab tu jadi circuit breaker.
Fault.
Fault tu.
Fault sebab fault current tu lah. Okay. Contoh fault current ni lah lightning. Contohnya kilat, strike dekat sini. Current asal kita dia tengah lalu kat sini, contohnya 1000 am. Current bila kilat strike ke kawasan tu, ke line ni, ke bus ke line, dia naik sampai 10,000 am. Jadi current yang tinggi tu bila dia dah dia detect dengan CT dengan BT tadi tu, current transformer, voltage transformer. Okey. Jadi dia akan arahkan inilah apa circuit breaker ni untuk buka circuit. Jadi current yang tinggi tu tak akan keluar daripada zone ni. Dia habis kat sini je. Nak terbakar dekat sini je. Zone lain tak terbakar lah. Current yang tinggi tu tak akan ke zone lain. Okey. Ada soalan? Okey, kita berhenti kelas di sini. Saya akan upload video, nanti saya akan letak link dalam kalam. Jadi apa-apa boleh refer kalam. Okey, terima kasih semua. Assalamualaikum. Have a good day.
Waalaikumsalam.
Okey, tutup kelas kita dengan tasbih kafarah surah Al-As.
Thank you, sir.
Welcome.
Slide dapat.
Ya. Ada soalan? Hello? Siapa yang cakap tadi?
Slide tu dekat mana rasa?
Ha?
Slide. Kalau tak ada pun saya tengok.
Kalam patutnya ada dekat power system protection punya ni lah.
Ya, saya check.
Awak cuba buka awak punya kalam, share screen.
Okey, jap.